Algebra 1, we're going to be talking about 1.2, solving multi-step equations. The essential question for this lesson is, how can you use multi-step equation to solve real-life problems? Core concept. To solve multi-step equations, simplify each side of the equation, if necessary. Then use inverse operations to isolate the variable. The first example is solving a two-step equation. The question is, solve 2.5x minus 13x equals 2. And then they want you to check your solution so the answer is right. Okay, the solution is, you write the equation first, and you add 13 to each side to isolate the variable, as it says right here. Then simplify, so just add everything together. And then you divide each side by 2.5, as they do here, to get the value of x. Then once you do all of this, you get x equals 6. But we don't know if this solution is right, so they make you check it. To check it, you just insert 6 for the x value, and if you get an answer equals the same answer, then it's the right answer. So in this case, it's 2 equals 2, so it's right. Example 2. Combining like terms to solve an equation. Solve negative 12 equals 9x minus 6x plus 15. Check your solution. Okay, first step, write the equation as it does here. And then combining like terms. As you see, the 9x and 6x are like terms because they both have x to the same degree. So you can just subtract all of them. So you get 3x. And then you subtract 15 from each side to isolate the variable. After you simplify, you get negative 27 equals 3x. And then you have to divide each side by 3, and you get x equals 9. Then for the check, you just insert negative 9 for x, and the answer comes out to be the right answer. Using structure to solve multi-step equation. Solve 2 times x minus 1 minus x plus 3 equals negative 8. Check your solution. Method 1. One way to solve the equation is by using the distributive property. Write the equation as it does here. And the distributive property is when you're multiplying something in a parentheses, you can multiply the value on the outside by each number in the parentheses. So here is 2 times 1 minus 2 times x, as you see right here. And then multiply them, so multiply these two. Combine the like terms, as I said in the previous slide. Subtract 5 from each side to isolate the variable. Simplify. Divide each side by 2 to get the answer. And this time the answer is a decimal, 6.5, but that's okay. And then here's the check, and it works out. Then here's the real life example I was talking about earlier. Example 4, modeling with mathematics. Use the table to find the number of miles x you would need to bike on Friday so that the mean number of miles biked per day is 5. Then here's the chart here. Monday 3.5, Tuesday 5.5, Wednesday 0, Thursday 5, and Friday is x. That's what we want to find. Solution. Understand the problem. You know how many miles you biked Monday through Thursday. You are asked to find the number of miles you need to bike on Friday so that the mean number of miles biked per day is 5. Step 2. Make a plan. Use the definition of mean to write an equation that represents the problem. Then solve the equation. Number 3. Solve the equation. The mean of the data set is the sum of the data divided by the number of data values. Then here's our equation, 3.5 plus 5.5 plus 0 plus 5 plus x all over 5 equals 5. And then combining the like terms, 14 plus x over 5 equals 5. Multiply each side by 5. You do this so you can get rid of the denominator 5, as these two cancel out, and then you can just multiply this side by 5. Then you simplify. 14 plus x equals 25. Subtract 14 from each side, and you get x equals 11. By this, you know that you need to bike 11 miles on Friday. Step 4. Look back. Notice that on any days that you did bike, the values are close to the mean. Because you did not bike on Wednesday, you need to bike about twice the mean on Friday. 11 miles is about twice the mean, so your solution is reasonable. Thank you guys. If this video helped, please consider liking and subscribing. It'll mean a lot.